I want to respect your time, so we will get right into it.
Yeah,
So, Dr. K, can you please just tell us about your background and your education path and how you've gotten to this position?
sure, sure. I was always interested in the brain. My father's a physician, and actually, it's an incredible odds ratio. A lot of times, children of physicians become physicians. They get exposed to it. But it's probably also genetic, obviously, the way you process information. But I was always interested in the brain, and I got into one of those accelerated programs. It doesn't exist anymore at Northwestern, and I was able to start doing neuroscience from my second year in college. And I just fell in love, and I've kept on staying in love. And then in med school, I did do a year between preclinical and clinical in a electrophysiology lab, voltage clamping with Toshio and Arahashi. That's tetrodotoxin. And then I did residency and fellowships at University of Pittsburgh Medical Center. I was at Northwestern, and I was very, very fortunate. They had a wonderful mood disorder program, and they were doing a lot of the cutting edge work, clinical on mood disorders, developmental. So I got to work with that group, and I found it a little bit unsatisfying for me personally because it was, a lot of the data obviously is based on clinical observation.
Hmm.
And if you're curious about the brain, it's a little bit annoying because it's very distant from the brain. So I got very, very lucky. And I ended up working for a few years in David Lewis's lab. And he is like a leader in postnatal maturation of non-human primate prefrontal microcircuitry. And he's done a lot of his work in schizophrenia, but obviously there's a lot of correlates with autism.
Hmm.
So I have a really strong family history for autism. I've always been interested in it.
Hmm.
So it's just been like a passion and a love. And as my career has evolved, I've been able to focus more and more on autism spectrum, which I enjoy a lot. I mean, I'm a board certified general, but a lot of the practice in that direction. But I still
Hmm.
like reading neuroscience and talking about it. Yeah, yeah,
Amazing. Oh my gosh, thank you. That's amazing. Yeah, your education path, I mean, that advanced program, I mean, that is incredible. 6 years, right? From
yeah,
undergrad to med school. I
yeah.
mean,
They
that is.
don't. But they shut it down. Actually, it's interesting because it was a lot of doctors' kids, which it was a lot of doctors' kids,
Oh,
and
uh-huh.
so it's not necessarily a population you're really trying to recruit because a lot of them become physicians anyway. So
Right.
they closed on that program. But I really I liked it a lot because it's so long, the training, and it was nice having time to do extra neuroscience training on the back end. So I was able
Hmm.
to. It didn't feel quite as painful, although I enjoyed it, the extra time. Yeah.
Wonderful. Thank you. Wow.
Yeah.
So
Oh,
can you,
so do you want me? I'm not sure. Do you have questions for me, or do you want to? So it's for mental health. Did you want me to talk about like college mental health or neuroscience?
You're so good. Yeah, so we're gonna like, if it's okay with you, we're gonna like progress through
Oh
so we
yeah,
have like more
sure.
like focused on you and then
Yeah,
like
yeah,
if you have any advice. Yep. So I
absolutely.
think Caroline has the next question.
Sure.
yeah, and do you want me to ask two or three? Because you kind of answered two.
You can do whatever you want, Caroline. But whichever feels best for you.
So could you tell us more about how neuroscience impacts how you treat people and how you see psychiatry as a field?
Absolutely. Absolutely. That's a wonderful question, Caroline. And just for fun. Oh, I think you disabled screen sharing. I was going to share a slide, but the essentially, as I said before, psychiatry can be both frustrating and exciting because it's really based on clinical observation. So we actually have no diagnostic tests that are brain-based that have any validity. So it's and also the brain is such a privileged organ. It's such a unique specialty in medicine because you don't have access to biopsy. So it it makes knowing the underlying science background beneath the medical specialty, I think, mission critical to having a more effective way of approaching mental health. So, for example, for autism, that's a really strong example, but it's, like all mental health disorders, it's incredibly brain-based, and it's incredibly genetically driven, arguably the most, probably about at least half the heritability for expression. And understanding neural circuitry shifts and when they occur, it just gives you so much more power in terms of understanding like why a person's experiencing challenges and what to do in terms of available interventions, and understanding like developmental windows and when to do what, and what you would expect to see when. And it's just, I think it just helps so much. So the metaphor I like to use is that if, when you're using something like a DSM nosology, it's almost like the story of the blind men feeling an elephant and trying to guess what they're feeling, and each person feeling a different part of the elephant. And with the DSM, a lot of the differential between different disorders is reliant on that criterion B, associated symptoms. And that's a 5 out of 9 criteria. And I don't remember my factorials, but I don't know if that's close to 300 different permutations. And the underlying individual constructs actually overlap within disorders. So something that's reliant on like higher order circuitry and more complex processing is going to break easy. So the construct of attention is present across all the major psych disorders. So there's something called diagnostic creep as you get more severity, and you just get lack of clarity in the landscape right when you need clarity, when things are difficult, because their severity of symptom triggers more symptom number. So the underlying neuroscience, I think, is I really feel it's totally changed the way I practice medicine, practice psychiatry. And I think it makes it a lot more fun because you can change outcome, I think, more effectively, more cleanly. And it's challenging because, and you guys are very fortunate to be studying neuroscience. You're actually not required to take a single neuroscience class to become a board certified child psychiatrist. They do test you on neuroscience, and the exam questions in neuroscience for board certification or maintenance, they're very, very like elementary, like stuff that you would probably be able to answer if you studied effectively, like at an undergrad level. So I don't know, I just think, and also it's such an incredibly interesting arena where like the more you learn, the more you definitely know you don't know that much. So you guys are lucky, you actually probably are getting a chance to look at molecular genetics quite a bit, but we didn't even have genome sequencing when I started, and all these new things like CRISPR, we didn't have that stuff. So thank God I started with PATH. Yeah. But the neuroscience, I think, is amazing. In fact, for what I do for living psychiatry, the incoming class for a major, like a Top Gun academic program, about half their entry were MD, PhD for psych. And I think it's one of those specialties where it has so much transparency and awareness that obviously understanding the underlying brain basis for the expression and presentation of mental health, how could it not change outcome, So, it's really beautiful.
Yeah, I agree. I feel like it's really empowering for people when they have like a better understanding of their brain, to really understand diseases. And so it's nice to like see how neuroscience impacts clinical outcome as well. So what do you find most rewarding about being a psychiatrist?
Well, it's all based on outcome, and it is, I think, very gratifying to change outcome. So, there are so many important areas in mental health. So there's a really severe illness, schizophrenia, where it's harder to change outcome because the aspects of the neural circuitry involved are very higher order, very severe, and the treatments we have are really suboptimal. In fact, it's interesting, the utilization of like first-line treatment, like full-go antipsychotics with high receptor occupancy first, right? Dopamine 2 receptors is the typical definition. You lose 20% of your astrocytes, 12% of your oligodendrocytes in non-human primates associated with thinning of gray matter index on volumetric MRI, longitudinally in human, with data points going out more than a decade. And obviously, those are things you generally don't want to see. So it's And it's interesting with what I do for a living, because oftentimes, it's a big nationwide experiment right now, giving young developing brains these pretty aggressive doses of antipsychotics, actually higher than adults sometimes if you think about it from a milligram per kilogram basis. And I think I think we don't really know yet what the implications are, but I think if you look at it from a neuroscience perspective of like what the meds actually do to the brain, it is far more of a cautionary light. Whereas like if you just look at routine clinical syndromal data, like the big one is the Rupan, the McCracken, the big NIH multi-site, like a standard fold in and out across open and closed label. The really big positive finding is use of antipsychotics second generation for irritability and autism. It's like 1 to 2 FDA indications. So not surprisingly, understandably, people are going to use antipsychotics, and they're so high potency. It's very easy to get to high receptor occupancy, like full antipsychotic load. And that side effect is dose related by volumetric MRI. So, there's all this stuff that's interesting. Did I kind of get your question or? Okay.
Yeah, you're good.
Okay.
So speaking of these really interesting outcomes, are there any cases that changed how you view things, either positively or negatively in your career?
Certainly. When I first left neuroscience, I was at a program where if you're interested in research, they were very, very happy and enthusiastic to support it. So I was doing my clinical training, but at the same time, I was already getting the opportunity to do like research in a research focused direction. And actually, strangely enough, I fell in love with the mood disorder group, and I was working a lot with the mood disorder group. And there's a brilliant, famous researcher actually in autism, who actually one of my colleagues, one of my classmates at residency, he's head of the Stanford residency program now. He ended up doing research with her, but I was into mood disorders then, and I didn't really know that much about autism. One of my best friends from med school actually wanted me to look at her son, and I didn't feel as confident because I didn't feel it. So I've been learning on my own on some level as I've gotten out. But I could see that even from the beginning, I was really curious about using a neuroscience approach. I could see I was getting better outcome than a lot of people, because there tends to be a very stereotypic way that you approach problems that are based on like tiered protocols for meds, like first line, second line, and you tend to follow that. And there tends to be a lot of repetition of different drugs in the same class. So for example, you'll meet someone that's been on 1 million different SSRIs, like Prozac, Zoloft, Paxil, Daxalex, Electropro, which while they have different molecular structures, they're all the same med in terms of binding constant. And seeing that, like approaching the meds in a different way and helping people was very, very gratifying. And then, realizing that there's so much to know and so much of your skill is based on clinical experience. It also is very humbling and makes you realize that, there's so much to know. You really have to be sensitive to the skew in your skill set. So I feel very confident about doing certain things because I've had not just the intellectual exercise of like learning it from a neuroscience perspective, but actually real clinical repetitions and playing with meds and stuff like that. Whereas there are certain arenas where I really actively avoid because I just feel like I don't like, you close doors when you open doors, and I've been opening doors in one direction. So I'm exquisitely sensitive to the fact that like I've become very, very stupid in many arenas as I've become more knowledgeable in some arenas. So like dementia and addiction, and there are certain things where I just feel like I'm like bottom of the barrel pond scum, where it would not, and it's very evident to me, like I just don't know what I'm doing. Like you really have to get a sense of what you know and you don't know. And then obviously when you do this for a living, like you do have the opportunity to save lives, but also it means then some people will die. And obviously whenever that happens, it's a time for reflection and thinking about what you could do differently. And certainly that's, influenced the way I approach things over time. Oh.
That's really interesting. Are there any therapeutic or self-care techniques you prefer to use in your practice?
Well, honestly, I'm like really a brain mechanic. So because it's harder to find people that have a neuroscience background, and there are so many brilliant people that do other arenas, like I am usually best off staying in my lane. But as a routine entry level thing, if you looked at data, obviously one of the biggest things that has a lot of interest is mindfulness techniques. And having the ability to utilize mindfulness techniques as clear data for mental health outcome. And that's why it's like something that they're starting even like in Head Start, Denver Head Start. And, there's a ton of data. The other thing is that a lot of times when you're talking about psychotherapy techniques, it's interesting to look and see if there's any interventions that have really good data, especially if there's any neuroscience correlation. So there is a technique by Lanahan called dialectical behavior therapy, where they talk a lot about the dialectic, the opposite poles of having to approach a problem with acceptance versus change. So like giving yourself grace to accept your challenges and at the same time aspiring to overcome the challenges and having the grit to push through the discomfort. And having, obviously getting exposed to these manualized techniques can be very, very helpful and are becoming increasingly available online. The other thing is that, we're so aware now that the brain is such a powerful organ, very, very complex. Developmentally takes a long time to mature to take advantage of the complexity. It's very, very vulnerable. And there's such powerful data, not just in psychiatry, but even stuff like neurodegenerative, like Parkinson's, how things such as exercise and sleep and nutrition, like brain health, are mission critical. Or like for college students, it's really, really interesting. Like it's the concept of stress and how you approach stress is really, really important. So, we think actually, if you look at a really, really big picture of like psychiatric interventions, there's actually been some question in the academic world about the construct of how do we approach stress in terms of helping people, because we know that if you look at genetic activation profiles, when you stress an organism, it looks like the majority of genetic changes are actually adaptive. And we have such a complex, powerful system, it's highly counterintuitive to expect that we could fully take advantage of what we have without stress conditions. So you're a college student, you're studying hard, you're like anyone else, like just the fact that there are metrics and benchmarks, it would be hard to have the discipline to do that on your own. It pushes you to push through more things than you might want to do, although sometimes you wonder, like I did help deliver a baby. I'm not sure how useful that was, but it happened. But it's good to be stressed out. And then the construct of how you adapt to stress and what happens under stress is very, very predictable, like hyperfrontality, increased basal ganglia tone, negative cognitive looping, increased limbic tone, amygdala tone, anxiety, irritability, the challenges with sleep, and being sensitive to it and trying to be aware of this stuff is really mission critical, to effectively handling things.
100%. That's really interesting. Oh my gosh. Okay, so my next question is, do you have any advice in people that are interested in research, whether it be neuroscience or just in general?
Yeah, definitely. I think you guys are very, very fortunate that you have so much access to really top gun laboratory, and you have access to a neuroscience major. So I would say, if you think about what you're going to be doing for the rest of your life, if you're really deeply and desperately in love with neuroscience, I would just take it as much as you can and go as far as you can in terms of what's available. So, like when I was in med school, it was just a lot of information, which you do have to know, but it's almost like you have to triage your time, where you're juggling and you're doing enough to like hopefully pass everything. Like I got very borderline with OB-GYN. I remember, like I was just answering biopsy for everything on the clinical exam. I thought, oh my God, it's my first rotation, I'm going to flunk. Although I was wrong, I'm surprised at how much I actually have to know about sex hormones for the brain. But I knew that whenever I was getting exposed to anything that I thought might be thought relevant to neuroscience, I really tried to go above and beyond. And like even now, like you know, I'm not doing research, but I go more to the research meeting, the biological psychiatry meeting, and I like the vast majority of research reading I do is actually neuroscience literature. It's not like direct clinical literature because it's such noisy data. I find it, you know, it's a bit frustrating, you know. So, but I would just say pursue the passion and just work as hard as you can. And I think it's also good to get exposed to laboratory stuff, you know, just because it's just a different ecosystem than being in a book. And it helps to understand like how information comes about and how you get it.
100%. Thank you so much.
Yeah, yeah.
And then do you have any advice for people who are specifically interested in psychiatry?
Well, I do. I would say I'm very biased. So there's different ways you can do mental health. So some of my colleagues are very good at talking to people and doing psychotherapy stuff, and they would have different advice, which make a lot of sense. But for what I do, I'm just so grateful that I got a chance to do neuroscience, some introductory neuroscience sequence when I was still a teenager. And I'm really grateful that I did take a year off between second and third year in med school and I started to get a taste of laboratory neuroscience. And it made me more confident pulling the trigger on doing laboratory-based neuroscience when I finished clinical training, when I finished my child psychiatry fellowship. So I think it's hard. It's one thing to imagine it, and it's another thing to experience it. So I think it's just like once you're in it, you'll feel like how it feels. Like it's hard to imagine until you live it. And it's I don't know, I just think it's so informative to have those life experiences. And I think it's so fortunate you guys are in a Top Gun program where you have access to great didactic instruction, but you also have great access to labs, you know. And so I would say it would be nice to take advantage of it. You know, I'm biased, so I would say, you know, it's really cool to look at something like to look at laboratory-based stuff for a bit. Of course, I'm incredibly biased. So, you know, because the brain is such a privileged organ and it's difficult to assess, I'm really biased, and I think it's so elegant and clean intellectually to go to more controlled models and think about animal literature, animal models. So I'm just, it was like by an act of God that I got to work in David Lewis's lab. Like he completely changed my life, like getting to work on non-human primate prefrontal postnatal maturation microcircuitry. I just feel so lucky that I got my deep introduction into neuroscience in that arena, because I think it changes the way I do things. So like I'm giving a lecture in January for the annual, oh, are we done? Okay. For the annual card meeting, it's something other people are really interested in, because, you know, if you're a clinician and if you don't have neuroscience background, if you have a child or if you're a individual that has it, like I think it's just a natural emotional reaction to want to try and understand, like, you know, what's going on and why. And obviously the knowledge gives you power. Yeah.
Absolutely. Oh my gosh. Yeah, I came in as a pre-med student and now I'm pre-PhD. So I just fell in love with neuroscience and I'm in a lab right now and I'm hoping to secure funding to go to a conference. I think that'll like further my
Oh,
understanding.
yeah,
So
you have to go to Society for Neuroscience. Like
I
it's closed
want to
down.
so
Oh no,
bad.
no, it's mind blowing. You'll enjoy it a lot.
I'm really
But I feel
excited.
bad. I actually blocked out a patient at 10, so I'm gonna have to wrap up in the near future. I just want to let you know.
All good, all good. Is it okay if I just send you a question about like your tips for mental health and like avoiding burnout over email, or would you prefer to answer that right now quickly?
One, you know, actually, I might have a friend do that. So Cheryl Checkers, who I work with a lot in autism, she's good. But a big thing is you do want to rest, and then obviously with the kind of work you're doing, it's memory consolidation work. So I'm sure you guys already do this, but it's in your best interest. You've already figured this out. Like you know, you don't want to cram. It's an unnecessary amount of stress and it degrades performance. because obviously those that heavy in learning, like you can only do stuff in like the spindles and shortwave and all that kind of stuff. You can only do so much. And you know, a lot of it is just letting your brain rest if you're going to push hard. So I think a common error I see when like students are like decompensating is that they haven't been it's good to work hard, but then you actually have to rest hard, you know.
Absolutely.
The one
Thank
thing I
you.
Oh no, it's so nice to talk to you.
Sorry.
No, I'm happy to talk to new generation. That's absolutely.
Thank you so much.
Thank you so much.
Okay, have a great day. All right.
Thank you. You as well.
Thank you. Very fun.